What we know that is when we studied, we came up with the atom as the smallest chemical piece, and it was made up of protons, neutrons, and electrons, right? And because we look smaller, the further we started looking, the smaller we started finding. And so we found that the protons and the neutrons were actually almost all empty space with little tiny pieces that made them up called quarks. Okay? And so, oh my gosh. And so the smaller pieces, the electron, the positron, and the neutrino, really are very fundamental elemental particles, the smallest pieces that we think we can get. Okay? They're called leptons. The hadrons, which are protons and neutrons, actually have mass, and those are made up of little particles called quarks. And when we get down to these little particles, we call them elementary particles, but some people had called them subatomic particles because they were smaller than the subatomic particles. And so the more we look, the more it is little tiny specks of nothing. And actually in a paper that a scientist who wasn't a Christian wrote, we were kind of made up of little pieces of nothing. And do you know when you read the Bible, what God did? He put together nothing and created something. Now, a scientist would never, ever agree, but they just described what we believe fundamentally is that God took little pieces of nothing and made all that we see. And so these pieces are there. It's your own way of looking at the world, how you interpret it. Okay? Where we see design, some people see chance. Okay? There are some odd particles like the positron. The positron is the same shape, the same size, and looks like an electron. It's just got the wrong charge. It's called an antiparticle. A proton's antiparticle would be an antiproton. It would be the same size, shape, except a negative charge. We haven't seen very many of these, but we do see positrons. Here's what happens. If an antiparticle and a particle get together and touch, all of the mass is converted into energy, and it's called an annihilation. And it can be a lot of energy. It's actually governed by an equation that you might know. E equals mc squared. And c is a number that is that, and you square it, so it's a huge number. So a little tiny bit of mass can make a huge energy. And so since the electron and the positron have almost no mass, when they do get together, it gives off a little bit of energy in the form of gamma rays. Okay? And so we actually use radioactive material to give off positrons, and they annihilate to create gamma waves. But we do it in a really strange way. We use it in the medical field. Okay? And so what we do is we take radioactive material and inject it inside of us. Does that sound like something you want? Okay. Well, the half-lives are within minutes, so it decays very rapidly. You are exposing yourself to a little bit of harm, okay? But it could see a tumor in the middle of your brain. The only other way to see a tumor in the middle of your brain is to cut into your brain. Does that sound healthy? No, it's inoperable, but you can actually see using that in other places, okay? And so sometimes you take a little bit of risk for a little bit of reward, benefit. Just like going for an x-ray, right? If you broke your arm, you go in for an x-ray, they make sure it's broken so they can set it right. Because if it heals wrong, you could have problems the rest of your life. So you take the chance of a little bit of exposure to radiation, a little bit of risk, for a huge potential reward. How do you know it's a risk? The radiation tech goes in there, sets you up, and then runs away, right? They're not even in the room. Why? Well, you're going to get an exposure once or twice. If they were in the room, they would have exposures every day. that would really increase their risk. And so they get out of the way, okay, but you need it, and you're going to take a little risk for a lot of reward. Taking a little bit of radioactivity for a certain test may give you a outcome that helps the doctors treat you, and so you take a little bit of risk for a lot of reward. The kind of things that we do is called a PET scan. You may have heard of it. It's a positron emission tomography. The positron will emit gamma rays when it hits an electron, and then I can measure it. Also, it's used quite often for looking at cancers, because cancer cells take up the material much quicker, and so you see a distinction between a cancer cell and normal cells. And so this is used both in Alzheimer's and in cancers. And it's the basic principle of an antiparticle annihilating, and we can detect that energy very well, because the energy will go right through your body, and so we can detect where it is.